In this video, we will show you how to use VEGA to model complex surfaces from a point cloud and create solids from them. We will demonstrate this using an example of modeling a road segment that includes a rise, curve, and slope. The result is an AutoCAD solid object that can be imported into Revit or other programs for further modeling. On the screen, you see a point cloud of the road segment. Let's look at it from above and draw a 2D polyline approximately in the center of the road. This can be either a straight line or an arc. The resulting polyline is at level 0. As you can see, the road has both a curve and a slope. Now let's create dynamic slices using the Create Dynamic Point Cloud Slice command, which is called Slice by Polyline Salami. This is a powerful tool for creating different types of point cloud slices. We select the polyline and the point cloud. We can make slices by world coordinate system, by custom coordinate system, or by current view. We work in metric coordinate system. Unit of measurement in this drawing, meter. We set the minimum and maximum distance between slices, the number of intermediate slices, and the thickness of the slice. Also set the width of the buffer that defines the outer boundaries of the slices. Let's look at the road from the side and change the transparency. We can select the required number of slices using the Browse Dynamic Point Cloud Slices command. We start at 1 meter and end at 6 meters. The number of slices depends on the accuracy with which we want to draw the road boundaries. Let's change the type of point cloud representation to normal in order to see the corners of the road accurately. Now we need to draw 3D polylines along the road at all corners to get a wired model of the road. You can use AutoCAD's 3D polyline command with OSNAP to the point cloud, but I suggest using the VEGA command called Polyline by Point Cloud Cursor. It's similar to the AutoCAD command, but it doesn't make mistakes. If you specify a point that is not on the point cloud, it simply won't be drawn. As a result, we get a wired model of the road. Polylines must start from one side. We have obtained the internal surface of the road. Now let's define the external contour. We can make a flat surface at the bottom, or we can make a profile. Let's make a profile. For this purpose, we will use the 3D offset command. We copy the side lines down by 20 centimeters and make the internal lines offset to the side and down by 20 centimeters. Thus, using the internal surface lines, we get a wired model of the external surface. Let's turn off the point cloud. The quality of the future solid depends both on the number of vertexes on the polylines and on the fact that on all polylines the number of vertexes is equal. For this purpose, we will use the command equalize the number of all polyline vertexes, setting the value 100 for the number of vertexes on each polyline. To create solids, we use the command Create 3D Solids by Irregular 3D Polylines. This command has two options, using multiple polylines and using groups of 4 polylines in sequence. We will use using groups of 4 polylines in sequence. We will talk about the command using multiple polylines at once in the video about creating solids from curved walls and surfaces. We create a road profile by selecting the first polyline, then the second one, then the first one again, then the second one again, and so on, until we get a solid. Change visual style. to union all solids into one. We use the union command in VEGA, which works more accurately than the standard AutoCAD union command. Change the color of the polylines that form the wireframe and turn on point cloud. We have a solid object that can be used in AutoCAD or imported for further modeling in Revit. Let's import our solid into Revit. Create a new project. We're working in the metric coordinate system. Select Component. Model in place. Mass. Insert. Import CAD. Select the drawing containing our solid. Import units, meters. Center to center. Finish mass. We can change the presentation. Let's choose Realistic. We can remove the lines, of which there will be many, because we have made a solid that represents a surface curved in all directions. Graphic display options. Turn off Show Edges. We can add some shadows. As a result, we have a mass element that we can continue to work with in Revit. Let's create a section as an example. Let's see the result. With VEGA, we can create solids of any complex surface, both from a point cloud and from ordinary AutoCAD polylines. Then we can import the resulting solids or meshes into Revit or other programs and use them for further modeling.